Right now, you're probably eating something, or about to, or scrolling through a delivery app trying to decide what crime against your arteries to commit tonight. And somewhere in your kitchen, sitting completely unnoticed, there's something that should not be edible. A raw kidney bean contains a toxin called phytohemagglutinin, and eating just 4 or 5 of them uncooked is enough to put a healthy adult in the hospital, vomiting violently within a couple of hours. A green-tinged potato is quietly producing the same family of poison found in deadly nightshade. Coffee beans, before they're roasted, are mildly toxic too. None of this ever crosses your mind, because by the time any of it reaches your mouth, all of it has already been disarmed. A koala can eat exactly 1 plant. A panda, despite having the gut of a predator, has narrowed its entire diet down to bamboo and almost nothing else. You, a soft, clawless, not particularly fast primate with a stomach no more impressive than a pig's, can sit down and eat almost anything on this planet. The reason has nothing to do with humans simply being smart. The actual evidence is genuinely stranger than that. Here's the trap most people fall into when they think about this. The obvious explanation is that humans just have tougher stomachs, or that being smart and inventing tools is somehow the same thing as being biologically built to handle anything. That explanation feels right up until you actually compare human digestive hardware to the rest of the animal kingdom. Because on paper, we're not impressive. A vulture's stomach acid is corrosive enough to dissolve the bacteria living in rotting carcasses, strong enough to neutralize pathogens that would kill almost anything else that touched them. And a vulture gets that from biology alone. No fire, no recipes, no group chat full of tips from grandma. Rats can sample an unfamiliar food, feel slightly sick afterward, and instantly learn to avoid it for the rest of their lives, building an internal danger map faster than any human ever could. If this were purely a contest of which species has the most heroic internal plumbing, humans wouldn't even crack the top 10. So the real question isn't why human bodies are built to handle anything thrown at them. Mostly, they aren't. The real question is where the actual advantage is hiding, if it isn't sitting inside your gut. And yes, we are absolutely going to get to the fish that's legally allowed to kill you if someone messes up the recipe. But first, we have to go back to the single oldest piece of technology your species has ever owned. Roughly 790,000 years ago, on the shore of an ancient lake in what's now northern Israel, at a site called Gesher Benot Yaakov, a population of early humans, most likely an early form of Homo erectus, left behind small, tightly clustered patches of burnt flint and charred wood, packed into distinct spots rather than scattered randomly across the site. That clustering is exactly the signature archaeologists look for to tell a wildfire that happened to pass through, apart from a fire that a group of hominins built, tended, and reused in the same place over and over for a long time. This is, give or take, one of the oldest strong pieces of evidence we have for habitual, controlled fire use. Not a fire happened once, but we know how to make this happen, and we do it on purpose. And once you have reliable fire, you have something genuinely new in the history of biology, a way to start digesting your food before it ever reaches your mouth. Here's the part that actually matters. Heat does 3 things to food that your digestive system would otherwise have to do the hard way at enormous energy cost. It breaks down tough plant cell walls, releasing nutrients that would otherwise pass straight through you unused. It denatures proteins, unwinding their tightly folded structure so your gut's enzymes can grab onto them more easily. And it gelatinizes starches, turning hard, barely digestible plant tissue into something your small intestine can absorb almost instantly. Cooking, in other words, is outsourced digestion. It's your stomach's work, done in advance, by something that isn't your stomach. A chimpanzee chewing raw meat or a tough root has to grind out every calorie using nothing but teeth, acid, and time, sometimes for more hours a day than you spend staring at your phone, which statistically is really saying something. You don't have to do that. Something else already did the expensive part for you long before the food touched your lips. But here's where it gets interesting, because that one shift, fire as a kind of external stomach, didn't just change what humans could eat. It appears to have changed what human bodies are. In 1995, two researchers, Leslie Aiello and Peter Wheeler, published an idea that's come to be called the expensive tissue hypothesis. And it's exactly as dramatic as this story needs it to be. Certain tissues in the body are metabolically expensive, meaning they burn a disproportionate amount of energy just sitting there, doing their job. The brain is the most expensive tissue you own. In an adult human, the brain makes up roughly 2% of total body weight, and yet it consumes something like 20% of your resting energy use all day, every day, whether you're solving a real problem or just lying awake at 2 a.m., wondering why you're still awake. Researchers have compared that constant draw to a dim light bulb running non-stop, never flashy, but never ever off. The problem is that the other famously expensive tissue in the body is the gut. A large, muscular, metabolically active digestive system also costs a fortune in calories to maintain, and evolution, generally speaking, does not like paying two enormous energy bills at the same time. Aiello and Wheeler's argument was that something had to give, and what gave was gut size. As diet quality improved, and cooking is one of the single biggest jumps in diet quality any species has ever pulled off, the human gut could afford to shrink, freeing up energy that got redirected somewhere else, somewhere expensive, somewhere that over a few 100,000 years helped build the very brain you're using right now to be mildly confused about why a video about food is making you hungry. So if cooking is doing so much of the heavy lifting, what is your actual body contributing to this whole eat almost anything situation? More than you'd think, just not in the way most people assume. Your liver runs a family of enzymes called cytochrome P450s, whose entire job is breaking down foreign compounds your body doesn't recognize as food, plant toxins, unfamiliar chemicals, things that were never supposed to end up in a bloodstream. Humans carry a notably broad set of these enzymes compared to many other mammals, which is part of why we can nibble our way through an enormous range of bitter, mildly toxic plants without dropping dead, something a more narrowly specialized animal often can't manage. And then there's your stomach. Research comparing gastric acidity across dozens of species has found that human stomach acid sits at a surprisingly low pH for a generalist omnivore, closer in fact to the brutally corrosive stomachs of scavengers and carrion eaters than to a typical opportunistic eaters. That level of acidity is extremely good at one specific job, killing the bacteria and pathogens that build up on food that's old, risky, or already starting to turn. Put those two systems together, a liver built to chemically dismantle plant poisons, and a stomach acidic enough to sterilize sketchy meat, and you start to see the real shape of the human advantage. It was never one single secret weapon. It's two separate biological systems, plus an external one made of fire, all stacked on top of each other, which is frankly a lot of effort for a species that still occasionally eats gas station sushi at 1 a.m. And this strategy didn't start with us. In 2011, researchers analyzing fossilized dental plaques scraped from Neanderthal teeth at sites in Iraq and Belgium found microscopic starch granules from plants like barley and date palm. And crucially, some of those granules showed exactly the kind of physical damage you'd expect from heating, not just chewing. Neanderthals, a separate human species that went extinct roughly 40,000 years ago, appear to have been cooking their plant food too, which means they eat almost anything as long as someone treats it. First strategy isn't even a uniquely Homo sapiens trick. It's something at least two different human species independently stumbled onto and built an entire survival strategy around, which raises an uncomfortable question for anyone who still pictures Neanderthals as the dumb, brutish cousins of the family tree. If eating dangerous food safely requires real planning, real heat control, and real transmitted knowledge, then whatever was happening around a Neanderthal fire wasn't survival by accident. It was a recipe too. Now take that same combination and watch what happens when it meets a genuinely dangerous food, full stop. Cassava, also called manioc, is a starchy root that feeds more than 500 million people worldwide, and in its raw, unprocessed form, certain varieties contain compounds called cyanogenic glycosides, chemicals that release actual cyanide once they're broken down inside your gut. Eaten carelessly, raw, bitter cassava can cause serious poisoning, and yet entire regions of West Africa and South America have safely relied on it as a staple food for centuries, because somewhere, generations ago, someone worked out a multi-day process of peeling, soaking, grating, and fermenting the root that strips almost all of the danger out. Nobody alive today invented that process from scratch. It was tested, refined, and quietly handed down, mother to daughter, for longer than most written history has even existed. And cassava isn't even close to the most extreme example. Somewhere in Iceland, someone figured out that a shark that's actively poisonous when eaten fresh, its flesh carrying natural chemicals the body can't process safely, becomes a regional delicacy called hakal after months buried underground and weeks hanging to cure in open air. Somewhere in Japan, someone figured out that a pufferfish carrying tetrodotoxin, a neurotoxin so potent there's no known antidote, could still be served as fugu. Sliced paper thin by chefs who train and get licensed for years, specifically so they don't kill their customers. Yes, we're doing the fish that can legally kill you. No known antidote, and people still serve it to strangers for a living, bold business model. Somewhere in Korea, somewhere in Germany, somewhere on essentially every continent humans have ever lived on, someone independently discovered that burying vegetables in salt and letting bacteria quietly take over wasn't rot. It was a recipe. None of those discoveries required a different stomach. They required someone willing to almost die, a community willing to remember exactly how, and enough generations passing the knowledge forward that almost died finding this out eventually turned into tradition. Compare all of that to how the rest of the animal kingdom handles dangerous food, and the difference becomes obvious fast. A koala can eat eucalyptus leaves that are toxic to nearly everything else on Earth, but it took millions of years of evolution to build the specific liver enzymes that let it do that. And the trade-off is brutal. Eucalyptus is so low in usable calories that koalas sleep something like 18 to 20 hours a day just to survive on it. A giant panda technically still has the short, simple gut of a carnivore built for meat, and yet spends its entire life eating almost nothing but bamboo, extracting so little energy from each mouthful that it has to eat for most of its waking hours just to break even. A monarch butterfly caterpillar eats milkweed toxic enough to stop a bird's heart, and instead of breaking the poison down, it just stores it, wearing the toxin in its own body for the rest of its life like a built-in warning label. Every one of those is a brilliant solution, and every single one of them took millions of years, locked the species into one narrow food source, and can't be taught, transferred, or updated. A human toddler, by contrast, can be born into a culture that eats fugu or hakal or fermented cassava or all three, and simply learn it. No new genes required, no evolutionary waiting period, just a recipe and someone patient enough to teach it. But here's the part that should make you sit up a little. If the real engine behind humans can eat almost anything isn't really inside your body, if it's mostly fire, fermentation, and a few thousand years of someone's grandmother quietly debugging a poisonous root, then the trait that makes humans nutritionally exceptional isn't a body part at all. It's an idea, and it's transmissible for two genuinely separate reasons. One, an external process. Fire, fermentation, soaking, salting can do real chemical work on food before it ever reaches your body, neutralizing dangers no human gut alone was ever built to handle. Two, once a single person in a group works out how to do that, the knowledge spreads to everyone around them and to their children and to their children's children, without anyone needing to wait around for a new gene to show up. Put those two reasons together and you get a species that can absorb a poisonous new food into its diet within a single generation, a timeline no amount of biological evolution could ever hope to match. We've been asking why human bodies can handle so much. The honest answer is that biologically they mostly can't, not without help. Every time someone safely eats fugu or hakal or properly prepared cassava, they're not relying on their own digestive heroics. They're relying on a chain of strangers, most of them dead for generations, who took the actual risk so the recipe could exist at all. Now, let's be fair to the skeptic in the room, because there's a real gap here worth naming honestly. Humans cannot, in fact, eat everything. We have no enzyme capable of breaking down cellulose, the tough fiber that makes up plant cell walls, which is why a cow can live entirely on grass, and you absolutely cannot, no matter how much kale you commit to. Eat the liver of a polar bear, a lesson some Arctic explorers learned the hard way, and you can be poisoned by an overdose of vitamin A so severe it causes your skin to peel off in sheets, because the liver concentrates a nutrient your body needs in tiny amounts at a level thousands of times higher than is safe. And the cultural technology argument has a darker flip side too. It doesn't make these foods harmless, it just makes them survivable, and only if every single step is followed exactly. People still die from fugu poisoning most years in Japan, almost always from unlicensed home preparation rather than trained chefs. Cassava poisoning, when the soaking and fermenting steps get rushed or skipped, still causes outbreaks of a paralytic illness called konzo in parts of Africa today. So no, this isn't a story about humans quietly defeating biology. It's closer to a very long, very fragile truce, one where the price of getting it wrong hasn't actually changed in 790,000 years. Only the odds have. And here's the uncomfortable part of the story, the part that brings this all the way back into your kitchen tonight. The exact same trait that let your ancestors survive famine, drought, and entire collapsed ecosystems, the ability to find a new food source, make it safe, and crave it intensely enough to keep eating it even when it's scarce, never switched off once food stopped being scarce. For most of human history, the rarest, most calorie-dense foods were also the safest bets during hard times. So the brain built a powerful reward system around fat, sugar, and salt, the kind of craving intense enough to make someone in a famine prioritize a single beehive over almost anything else nearby. That circuitry is still fully active in you right now, with no awareness that it's no longer 50,000 BC, and that calories are no longer the scarce resource they evolved to chase. The modern food industry didn't invent that craving. It found it, studied it, and built an entire economy around triggering it as efficiently and as often as possible, engineering combinations of fat, sugar, and salt tuned to hit that ancient reward system harder than any single ingredient found in nature ever could. The same flexible, learnable, endlessly adaptable eating system that turned a poisonous root into a staple crop is now, for a great many people, working against them instead of for them. Not because anything in human biology broke, but because the environment around that biology changed faster than evolution or even culture could keep up with. We solved scarcity. We were not nearly as prepared for abundance. So here's the actual thesis. The thing every kidney bean and every piece of cured shark has been quietly pointing toward this whole time. Your ability to eat almost anything on this planet was never really about your stomach. It was never about your liver or your teeth or anything you were simply born with. It's about the fact that you are the current endpoint of an unbroken chain of people who tested the world's food supply, one terrifying, sometimes fatal mouthful at a time, and then made absolutely sure you wouldn't have to. Every meal you've ever eaten without a second thought, the beans, the cheese, the cured meat, the leafy green vegetable that would have been mildly toxic in its wild ancestral form a few thousand generations ago, is a small monument to someone you will never meet and can never thank. Cooking didn't just change what was on the plate. It changed what kind of animal you are. It's the reason your gut is smaller than it should be for a primate your size, and the reason your brain is larger than it has any biological right to be. You didn't inherit a tough stomach. You inherited a library written not in books but in recipes, rituals, and the specific way your grandmother always soaked the beans overnight without ever fully explaining why. Every time you cook something tonight, heat it, soak it, ferment it, season it, even just microwave it for 90 seconds without thinking twice. You're not just feeding yourself. You're running the single oldest piece of software your species has ever built on hardware that hasn't fundamentally changed in hundreds of thousands of years. You're not eating like an animal that conquered its environment through biology. You're eating like an animal that conquered it through memory. So let's go back to your kitchen. Same moment, same fridge humming in the background, same bag of dried kidney beans sitting in the cupboard that could put you in the hospital if you ate them straight out of the bag. Nothing about that bean has changed. It's exactly as toxic raw today as it was to the very first person who ever made the catastrophic mistake of trying it that way. What's changed is everything standing between you and that mistake: the pot of water, the heat, the 45 minutes of boiling that nobody questions because it's just how you cook beans. A step so basic it doesn't even register as knowledge anymore. It registers as common sense. But common sense is just inherited expertise that got passed down so many times it stopped feeling like a discovery and started feeling obvious. A koala will starve surrounded by anything that isn't eucalyptus. A panda will go hungry next to a field of food its own gut can't extract energy from. You could walk into almost any environment on this planet, hungry and empty-handed, and within a generation or two, the people around you would have figured out exactly what's safe to eat and how to make it that way, and then they'd hand you the recipe like it was nothing. Because to them, by then, it would be nothing. It would just be dinner. You're not eating with your body. You're eating with your ancestors' mistakes. Every meal is a museum. You just call it dinner. So, what's the one dish in your family that nobody can really explain, except that it has to be made exactly that way? Let me know in the comments. Until then, see you soon.